Okay, folks, here's help on a couple of problems on the review sheet. The review sheet involves three types of problems. Things where they're the integral of 1 over something, where the integral of 1 over x is equal to ln of the absolute value of x, or a derivative involving ln. The other problems will be involving the derivative of e to the x, which is e to the x, and the integral of e to the x, which is e to the x. And we'll also look at problems involving, like a number 2 to the x. The derivative of that is 2 to the x times the ln of 2. And the integral of something to the x will be 2 to the x times 1 over ln of 2. Those problems will be coming up later in there. And the other types that we're looking at are drop the top problems, where if you take the derivative of an integrated function, there's a variable on the top, it just drops into the problem. So let's take a look at a couple of answers right here. Let's take a look at the first one. The derivative of y equals ln of x is y prime equals 1 over that function times the derivative of the inside, which is 7. And these almost always simplify down to 1 over x. So the next three problems, some are product and some are quotient rules. I will do the one. This is a quotient rule, so you can try that one. This is a product rule. I will try this one right here, the last one, which is a product rule. U is x to the 5th. U prime is 5x to the 4th. And V is ln of the sine of x. And V prime is equal to 1 over sine of x times the derivative of sine of x, which is cosine of x. And I can leave it like that if I wanted to, but I know cosine over sine is also equal to cotangent. So now for this one, I'm going to do u prime v plus uv prime. So I get 5x to the 4th times the ln of sine of x plus u, which is x to the 5th, v prime, which is cotangent x. I could have written down cosine over sine, and that answer would have been right as well. So the next type of integrations are all ln features. And remember, you're going to be looking for you can't integrate until you have the derivative of the bottom sitting on the outside. Now, all these problems end up working out very similarly to each other. I'll try this one with you right here. So the integral of x squared over x to the 3rd plus 5. Well, what I'm hoping is if I look at the bottom, I know the derivative of the bottom is 3x squared. I would need to have an x. Oh, I do have an x squared sitting around. I'm going to move that out to the side here. So I've got 1 over x to the 3rd. Oop, I have a trouble right here. 3rd plus. Okay, so I need to have a 3x squared in that set of parentheses over here. I only have an x squared, but I can counteract constants. I'll put a 3 in. I'll put a 1/3 outside. And the 1/3 stays. The integral of 1 over something is the ln of the something plus c. Okay, where it says find the derivative, when we're taking the derivative of something with a variable in the top, it's always going to be a drop the top problem. We're just going to drop the top in, but it keeps bouncing, because if it's a function that has a derivative that can be taken, we'll have to take its derivative as well. So the answer to this one is 3x plus sine of x minus x to the 5th. This function is going to be similar. It's a derivative one, so I'm going to drop the top in. So it's going to be cosine of x squared. I remember it that way, which means the same thing, plus 4 times cosine of x. But I need to multiply that by the derivative of cosine of x. It's like dropping it in, but I took its derivative and put it on the outside. That's times negative sine of x. The next page involves derivatives and integrals of mostly things involving ln. But take a look here. This one right here, for this one we're not doing, so don't worry about that. This one is a disguised drop the top problem. See, there's a variable up there. I'll let you figure out and see if you can find the answer for that one. We're not doing this one. And there's one. Oh, let's go take a look at one we are doing. This one looks short. It's the ln of that fraction right there. So that's equal to 1 over that fraction. sine of x times the derivative of the inside, which is the quotient rule. U prime v minus u v prime over v squared. That one was an annoying one, and I know it was long. Now, I'm going to hold up on that. This function is the derivative of an e to the x problem. So y prime is going to be 17 times e to the 5x times the derivative of the inside, which is 5. This problem has to take a derivative twice. So I take the first derivative, that's e to the 7x times 7. So I'm going to put that 7 on the front right here, just so it's there. And now I take the derivative of that again. Well, the derivative of that is going to be 7 times e to the 7x times 7. Now there's two 7s. And it's really 49. And this is a common problem they do. On ones like this, they might even ask you to do like d cubed over dx cubed of, they'll even do more, so they'll say 5, e to the 2x. Well, it just means that every time you take a derivative of e, another constant's going to appear out in front. But don't worry about that for right now. Here's the answer for this one right here. Now, a lot of them I didn't do because they're very similar problems. This problem, the other problems on here are mostly similar. We're not doing this one up there. That one's gone. The only one that doesn't look a lot like the others is this one right here. This is the integral of 5 to the something. Sorry, derivative of 5 to the something is 5 to the something times the ln of 5 times the derivative of the inside, which is 1 over x. This problem is going to be similar to that one as well. And in the end, we're going to look at these problems down here. We're going to integrate. Before I integrate, I make my parentheses. The derivative of the inside has to be sitting there. The derivative of the inside is 5. So I'm going to put the 5 there. I'll do 1/5 outside. The integral of e to the something is e to the something times the 1/5 plus c. Looking at the next problem, I see an inside function, sine of x. Well, I would need to have its derivative sitting on the, there it is, cosine of x. So I don't need to adjust anything. This part's just going to go. The integral of e to the something is e to the something. So I think I filled you in on a bunch of them there. There's a couple left over. We'll talk about them in class tomorrow. Take care.